All right, so now we're moving into these polynomials, which we haven't dealt too much with, so let's kind of look at this again. So, or look at this, what we're going to need to do. So if I've got a set of polynomials, and we need to write them as vectors, so we're writing the polynomials as vectors, here's the standard. So to take this polynomial, to write it as a vector, notice I put the constant in the first entry, I put the coefficient of the t in the second entry, and I put the coefficient of the t squared in the third entry. So if I tell you that this is a set of basis vectors, it is, I'm telling you, it is a set of basis vectors, then I want you to write out what this p sub beta is. So the p sub beta, I'm going to write this as my first column. So I'll have a 2 in front of the constants. I'm going to have a 0 in front of the t, and I'm going to have a 4 in front of the t squared. So for, let's just kind of do it in a different color. For this column vector, I'm going to have 0 constant, 3 in front of the t, -1 in front of the t squared. For this, I'm going to have a 1 constant, 5, and a -1. So this would be the change of coordinates matrix. So let's make sure we keep to that standard. All right, so verify that this basis, this set of vectors, is truly a basis. So how do we do that? So I need to verify that the set of vectors are linearly independent and span P2. So let's write them as a matrix. So again, this first column vector would be 1, 0, 1. This second column vector would be 0, 1, -1. And this third column vector would be 1, 2, 1. Okay. So it's going to be my job to make sure that these truly form a basis. So if I do row echelon, I get, okay, so what does this tell us? This tells us there's a pivot every row. So that means it spans P2. And there's a pivot every column, so that means they're linearly independent. So since it satisfies both, it tells me that this is a basis for P2. I guess I should write that for P2. Okay, so now we're looking to find the coordinate vector. So I'm wanting to find out, this means find the x sub betas, right? The numbers in front of the basis vectors that get me to this. So that means I'm going to augment and solve, right? Because I'm finding 1, 0, 1, 0, 1, -1, 1, 2, 1. I'm finding this vector right here that gets me to this, right? So if I augment and solve, this gives me this coordinate vector. So there it is. All right, so if I have this set of basis vectors, then the mapping from x to its specific coordinate vector is a 1-to-1 and onto transformation, because if I have a basis, again, it's linearly independent, pivot every column and pivot every row, right, to span this vector space. All right, so a 1-to-1 linear transformation is called an isomorphism. And so that's a word that we'll use a little bit this semester, but a lot next semester, actually. All right, if I have a set of basis vectors, and then any other set, so if this is the basis, if beta is the basis, then if I take any other set of this vector space that has more than n vectors, more than this number of vectors, for sure there'll be dependence, there'll be a relationship between them. So if a set of vector space has n vectors, then every basis has to have n vectors. So their basis vectors are not unique, but the number of them is unique. if a vector space is spanned by a finite set, so remember spanning is part of a basis, and V is finite dimensional, it's not infinite, then the dimension of V is the number of vectors that are in the basis. So it's just a fact that the dimension of the zero vector is just 0. So how many vectors need to be in a basis to span R3? Well, 3 vectors would span R3. How many vectors, because I can have a pivot every row, pivot every column, right? How many vectors span R2 and are a basis for, for P2? How many vectors do I need? So I need a vector for the constants, a vector for the t, and vector for the t squared. So this is also 3. How many vectors would I have in a basis for R4? 4. And how about for P3? That would be 4 as well. So let's just think of the standard basis for a set for P3. So you could have 1, and then you could have a 1 in front of the t, and then you could have a 1 in front of the t squared, and then a 1 in front of the t cubed. That would be your basic, your standard basis for P3.